All right. So in this unit, we are talking about systems of linear equations. If you're working on that Desmos activity, you are actually graphing two lines on the same grid. Okay? Those two lines, well, they could be parallel, but not always. Those two lines were referred to as a system of equations. System just means two or more linear equations that are related. So please write that down. Two or more linear equations that are related in some way. There's actually three different ways that they can be related. We'll talk about that in this lesson.
Solution of the system.
So one more time, system of linear equations is two or more. That's the system part. It's not a system unless there are at least two lines on the paper, okay, that are related in some way.
On the way. Guys, I'm just going to hold phones if I see them from here on out. I'm tired of asking. It's annoying.
Okay. Solution of a system is this. Right. Any ordered pair. What's an ordered pair? Yes.
Points.
Yes. Yes. It's a point on the XY grid that makes all the equations true. That means when you plug in that point, it makes the left side of the equation equal to the right side. Another way to think about this is, I could define this with one word. On a graph, it's the intersection. So you might want to jot that down. It's the intersection. Kind of like that. It's kind of like that. When an intersection happens, you have the line representing the ball, and then the line representing the person.
The quarterback of the safety.
That's right. Safety or cornerback who's intercepting the ball. So same idea. All right. There are three different types of solutions to a system of linear equations. Okay? One of them would be represented by this picture right here. How many places do I have an intersection here?
One.
So we call this the one solution case. Can you look at the graph and tell me what the solution to this system of linear equations is? What is the solution here, or intersection? 3, comma 2. Good. 3, comma 2 is the solution. Now, the next one right here, are these ever going to cross?
No. Yes. No solution.
Yes. They are parallel. There is no solution. They will never cross. Okay? Now, this third case here, guys.
Please don't talk right now.
The third case, can you tell this line is kind of it's colored differently from the other? It's because I have one line on top of the other. So this is the third case. I do have two lines. It is really a system. It's not just one line. Remember, to be a system of linear equations, I need two or more lines. So would you agree with me that there are two lines there?
No.
Two lines. Okay, one is on top of the other. How many times do they cross, those two lines?
Once.
Yeah, at least once. Infinite amount of times. So we say there are infinite solutions, or infinitely many. And so that's the third case. In this unit, the magic number is 3. We have 3 types of solutions. Either one solution, no solution, or infinitely many. How come I can't have 2 solutions to a system of linear equations? How could I? So here I have a system of linear equations. How come I don't have 2? I don't have 3 lines, that's right. So with only 2 lines, this line is not going to bend back around and cross again, right? Because then it would no longer be a line. So I can have one solution, no solutions, or infinitely many. That's it. We're also going to learn in this unit 3 different methods for finding a solution. One of them is graphing. The other one is substitution, and the other one is elimination. You may have heard of those before. So today we're just working on graphing.
Wait, don't change the slide.
So on the next page, if you flip it over to the back side, I'm going to show you the method of graphing to find the solution. So hopefully you guys are solid on graphing lines, okay? It's going to be important that you can graph two lines. So this line right here, this equation, is in what we call standard form. It was like the first two questions on the test you just took. I actually graphed those by finding the x and y intercepts. So what we do is we cover this negative x up. It's like plugging a 0 in for negative x. What does y equal when I cover up negative x?
Ooh.
Okay. And when I cover up y, what does x have to equal? Yes. So by plugging in 0, let's do it right now. Plugging in 0 for x, I get y equals 2. So my y-intercept is what? Can you tell me the coordinate of my y-intercept? Yeah. Okay, but that's not a coordinate. 0, 2 is a coordinate of my y-intercept. And then if I plug in 0 for y, I get, just like JJ said, this one is x equals negative 2. What's the coordinate of my x-intercept? Yes.
Negative 2, 0.
Yes. So if I go over here and I plot my 2 points, one at 0, 2, and the other one at negative 2, 0, I can draw my line. Now, when it comes to solving systems of linear equations by graphing, you want your line to be as accurate as possible. How could I make this even more accurate? What could I do? I could make another point. From this point to this point, I go up 2 over 2. So what should I do from this point to the next one? Up 2 over 2. And then down here, I can go down 2, left 2. So adding more points will help me to be a little more accurate when I draw it. Well, slightly more. Okay, or use a straight edge. Anyways, there's my first line. Okay? My first line. Now, with this second line, here's what we're going to do, Monty. We're going to go ahead and graph it using slope-intercept form. So here I have the intercept. What is the intercept according to that equation? Tara, can you tell me the intercept here? Okay. The intercept is where the graph crosses the y-axis. It's always this number that's not attached to the x. So the intercept here is just negative 2. So we have an intercept of 0, negative 2. So I place a dot at 0, negative 2. And then slope. Darian, can you tell me what the slope of this thing is? 3. And we usually list it as 3 over 1 so that I know what to do from this point. Can you give me instructions, Darian? What do I do from negative 2 if I want to do a slope of 3? Not sure? Okay. That's right. Daniel, what do I do if I want to do a slope of 3 here from this point? What should I do from 0, negative 2 if I want to do a slope of 3?
Go up 3, right 1.
Yep, up 3, right 1. Now, I haven't quite crossed yet. Do you guys see that? I haven't quite crossed my blue line. So what can I do again? Yes, by doing what?
We're going up 3 over 1.
Yes, up 3 over 1. And so what is the solution here to this system of linear equations?
Line 1.
No.
2, 4.
2, 4, good. It's 2, 4. It's the place where the two lines cross, right?
Oh, I remember this.
Remember this? So, here's what we can do to check this. Okay, if I've done this correctly, I should be able to plug in negative 2 for x. Looks like this.
Right now.
Yeah, guys, I need you to be paying careful attention here. I want you to see how I can check my solution. If I plug negative 2 for x in and 4 for y, it should equal 2. Does negative 2 plus 4 equal 2? And over here, if I plug in 4 for y, and I plug in 2 for x, is 3 times 2 minus 2 equal to 4? 3 times 2 is 6, minus 2 is equal to 4, so that's how we check our solution. Now, when it comes to systems of linear equations, they show up a lot in business applications. Okay? So we can compare like 2 different plans, 2 different business plans, that type of thing. And this problem, it says one satellite radio service charges $10 per month, right? Plus an activation fee of $20. Do we write an equation for that?
No.
No? What's the slope in this one? No, not -5. See this per month? Per month is a rate of change. That's my slope. So it's y equals 10x plus 20. Can you guys tell me how to graph the equation 10x plus 20? Somebody else decides to. Yes, Sophie, would you? Up 20? Yep. Yep. Up 10 over 1, up 10 over 1, up 10 over 1.
Sir,
I will. I always do. Okay, I'm just graphing it and I'll move. I always open up this way. Okay. So we go up 10 over 1, up 10 over 1, up 10 over 1, starting at $20. Okay? So what this is graphing is your cost per month for this particular satellite radio service.
It increases every month.
No, this is your cost. So every month you pay $20 up front. The first month you're going to pay 10 more bucks, so you're at $30. This is graphing the total amount of money you pay.
Joe, I don't think it's your fault. Oh, yeah.
Okay. What about this one right here, guys? I need you back up here. What's the equation of this second one? What's the equation of the second one, guys? $5 per month,
42.
plus $40 activation fee. 5x plus 40. When I go to graph it, I'm going to place a dot at 40. And this time, wait, guys, I need it quiet. So this time, I'm going to go up 5 and over 1. So halfway between 40 and 50, up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1. Oops, I'm going to stop right there. How come I'm stopping right there?
Because you already.
Yes. So what is my solution?
Henry.
What's the coordinate of my solution?
50 million.
No. I'm over 4, and I'm up 60. So in what month was the cost exactly the same for these 2 plans? Yeah.
3.
Not 3.
4.
At month 4, the cost is the same. Okay. So we can use systems of equations to solve that.
What is this?